Okay, so the last part of this section, part 2, is finding the sum. And we did this on arithmetic too. There was an equation where we found the sum of like the first 100 terms or the first 50 terms or whatever. So there is an equation to find the sum of, in terms. Let me find it. So the sum of the first in terms of a geometric sequence. Okay, again, this is something you need to write down. So Sn equals A1. This is just an equation that you'll just have to plug in numbers. Okay, this is R stands for ratio. It's the common ratio. N is the n number of terms. And A1 is the first term. Okay, so you need to write this down. This is the equation. We had 2 of them on the last section. It was like find the nth term, find the sum of the term, and remember from the previous video, finding the nth term looks like this. We just learned about this, was finding the nth term. Okay, so again, these are some equations you need to have written down. All right, so let's just apply it. Find the sum of the first 18 terms of the geometric series, sequence, 2, -8, 32. We kind of already done this one, but it was a good example because we had already seen it. So let me write down the equation. Oh, so we're going to do the n is 18. So we're going to do S18, A1, 1 minus r to the n over 1 minus r. Okay, so I'm going to just fill in the numbers. We know A1, there's A1, so 2, 1 minus r. What is r? So we're going to do A2 over A1, so -8 over 2, so -4. So our r is -4. So you got to be careful. This is where it gets tricky. This is -4. And then our n is 18. Now, when you're typing this in your calculator, you can't do 1 plus. This does not change. You've got to do PEMDAS. Let's all remember PEMDAS. If you're going to college, you definitely need to remember PEMDAS, okay? So, you can't do that. You have to do exponents first. Shoot, I'm erasing. Exponents first. So you have to do this part first. So please make sure you try this in your calculator maybe right now while we're doing this so you can get the right answer. Okay, so let's keep going. I got 1 minus -4. Okay, so again, this is mostly calculator, but you have to know how to put it in your calculator. This right there, that can be 1 plus 4, which is 5, okay, because you don't have an exponent. So we do just the addition or subtraction part of PEMDAS, okay? So if you're putting in this in your calculator, you've got to really pay attention to how you do it. And this is where it gets tricky and where people miss the problems because of this part. Now, if you want to put in 1 minus -4 in your calculator, you're going to have to put another parentheses around this. If you want to make it 5, that might make it easier. But you have to, when you do a little divide in your calculator, anything on the denominator has to be grouped together. So you have to do this in extra parentheses along with this part. Okay, so typing it in, you may want to try this in your calculator right now just to make sure you get the right answer and know what you're doing, because I'm not there to kind of help you along. It's a huge number. This is what I got. I'll make sure I wrote it down right because it's so big. So -27, 487, 790, 694. Okay, so that's the first 18 terms. So again, be careful putting this. You got to do, you got to put this incorrectly in the calculator correctly. Okay, so what that means is maybe you do -4 to the 18th power. Then you do 1 minus that number. Then you multiply it by 2. And then you divide it by the other number. Okay, so the last thing we're going to do is finding the sum of an infinite geometric series. Okay, so let's revisit the word infinite. Infinite means forever. And you might think to yourself, how can you add something that goes on forever and ever? Well, that's a good question. So there has to be something different about this series versus another series. So here's the important part of this. First of all, it'll tell you in the problem, find the sum of the infinite geometric series. And it looks a little different. They'll have these, instead of commas, they have like pluses and minuses here. So it looks a little different, but it's still the same thing. It would still be like if you wrote it like this. They just write it a little bit different for some reason. Okay, I'm going to erase that. But also, the thing with this is the common ratio has to be less than or equal to 1, okay, the absolute value of the common ratio. Okay, so that means it has to be, it has to be that you're dividing something every time. If you're multiplying this every time, the number's going to get bigger and bigger and bigger and bigger, and you can't add something that's going to get bigger and bigger and bigger. What has to happen here is notice these numbers are getting, if you put these in your calculator, these numbers are getting smaller and smaller and smaller and smaller, and they get closer and closer and closer to 0. So at some point out here in the infinite number here, this number is like tiny, tiny little fraction, and so you're just adding basically the tiniest little number, so it doesn't really matter. So that common ratio has to be less than 1. Now I say that absolute value, so it could be negative 1/3 or it could be positive 1/3. Okay, so it could be negative 2/3 or it could be positive 2/3. Okay, those are all acceptable ratios. If it's 4/3, that's 1 1/3, not happening. If it's 2, nope, can't do it. If it's 4, can't do it. If it's 7/3, that's bigger than 1, can't do it. If it's negative 4/3, still can't do it. Okay? Excuse me. If it's negative 7/3, can't do it. If it's negative 4, can't do it. If it's negative 2, can't do it. You get the picture. So if it's negative 1/4, you can. If it's positive 1/4, you can't. Okay? So again, there's a formula for this. All right? Let me give you the formula. I need to write this down. So sum of an infinite geometric series. Series is what makes it look a little different, but infinite's the word we're looking for here. So sum, it's A1 over 1 minus R. Again, A1 is the first term, and R is the ratio. Absolute value has to be less than or equal to 1, remember? Okay. Actually, it's not less than or equal to. I'm going to take that back. It's going to be just less than. It can't be equal to 1. So it could be 0.99999, but it can't be 1. I'm double checking on that. Yeah, okay. So it can't be 1. All right, so let's do the one I had on the front. I was writing it down so that I could do it and show you how this works. Okay, so this is what it looks like. And it'll indicate, find the sum of the infinite. Remember, we're looking for that keyword, infinite series. Okay, so first we have to find the common ratio. The ratio, remember, is A2 divided by A1. So we got negative 3 over 16 divided by 3 over 8. I don't have my calculator in front of me. So I'm going to go ahead and, when you divide, you multiply the second, oops, When you divide, don't you cry, flip the second and multiply. So I'm going to do that, and it's going to turn out pretty easy here. So I get negative 1/2. Well, guess what? That number fits in our less than 1 thing. Okay, so we can find the infinite sum. So I'm going to do S equals A1 is 3/8 over 1 minus negative 1/2. Again, just be careful when you do this. This is going to be 1 plus 1/2. Again, I don't have a calculator in front of me, so I'm just going to do this in my head. But you could probably do it in your calculator. But when you divide, you flip the second and multiply. These cancel. So I get 2/8, which is 1/4. So the sum of all of these numbers, it's crazy that it's this low, but its sum of all these numbers is 1/4. It's approximately 1/4. Now you're going to add on minuscule amounts, out in the infinite world, but the sum is 1/4. Okay? So again, make sure the ratio, check for the ratio. If it's a number larger than 1, absolute value, it could be -4 and it still doesn't work. Okay, then you can't find the sum of the infinite series. All right, and I believe that is it for this chapter. Actually, no, that's not true. We're going to do a couple of these. Let me look at my example here. Okay, so remember these from the previous chapters. Most of y'all probably figured out how to do these in your calculator, but I'm going to show you just in case. This is find the sum of the indicated number of terms. Well, the indicated number of terms is the first 7. Now remember our equation from before. We can still use that, or you could just simply put out the 7 and add them up, but you could also do it like this. So the first term would just be if you plug in 1 right here. So the first term is going to be 4 times -3 to the 1 power, which would just be -12. So that's going to be your A1. And then your ratio. So if you want to find the second term, so that would be 4 -3 squared. So 4 times 9, which is 20. Let's try that again. So 4 times 9, which is 36. Yes. Okay. And so you would want to find the ratio that way. You do A2 divided by A1, right? And you would want to do 36 divided by -12. What is that? Is that 3? Let me see. Again, I don't have a calculator in front of me. So it's going to be -3. So my ratio is -3. Okay, which makes sense because there's my ratio right there. Okay. And n is 7. So you would have A1, which is -12, 1 minus -3 to the 7th over 1 minus -3. Again, put that in your calculator. I don't have a calculator in front of me. If you want to know the answer to this, let me know. I don't have a calculator in front of me right now, so I'm not sure, but I wanted to make sure you knew how to do these. These are the same way. You just put them, you know what, I have a calculator on my phone. I'm going to use it real quick and get you the answer to this if I can. Take a minute. I'm going to write this down. So I've got 1 minus okay, so I'm going to do it looks like my answer is going to be this right here. Okay, so again, I just did this on my phone. I'm going to double check here in a minute, make sure I got that right. But you should be able to do this in your calculator. I do it in pieces. Notice I did this first. Then I can do the minus. I added 1 divided by, oh, you know what? This is not right because I divided by 4. Let me go back. Check this again. So 2, 1, 8, 7 plus 1. I'm going to multiply it by negative 12. And then I'm going to divide it by 4. Oh, I got the same answer. I just did it out of order. Okay, so I was right. I just wanted to make sure I was right because I'm doing it on my phone, and y'all know a calculator on your phone is a little quirky sometimes. I wouldn't suggest it. So I did this right here. I got 2187 negative. And if I add 1, I get 2188. You can multiply it by negative 12, divide by 4, and you get the answer. Okay? All right, let me know if y'all have any questions. This is due on Wednesday night. The other one's due Tuesday night. Get them done all at once. Then you'll have plenty of time to study for your test on Thursday. Your test will be open the same as it was before, 8 to 5. Let me know if any of that doesn't work for you. Let me know before the day of the test. If it's after the day of the test, there's really nothing I can do about it. So let me know before the day of the test if you have any issues. All right? Talk to you soon.